Hey, well done for watching this video. I'm gonna show you the secret to adding, subtracting, multiplying, and dividing SURDS. It is very important. The secret is in this video. If you want to be a very good expert, remember, I'm so happy. I love this topic. It's one of my favorite topics. It's amazing. Why? Because I don't have to ever use a calculator. It's amazing. It's amazing. Don't forget, remember to continue to work through the examples. Grab a pen, grab your calculator. All right, the calculator is just to check that you're doing the right thing. Remember, like I said in my previous video on SURDS, in this topic, usually when it comes in the GCSE exams, it is non-calculator. Okay, so it's important that we learn the skill and the secret. Okay, now in order to add, subtract, multiply, and divide SURDS, we need to understand that this particular skill actually works in the same way as we will add, subtract, multiply, and divide algebra. Okay, so that for example, in algebra, I know A add A is 2A, and I know A add 3A is 4A. I also know that 5x, for example, add 2x is 7x. Okay, however, I know that x add y is just x add y. I cannot add them. Why? Because they are non-like terms. So we know that non-like terms cannot be added. They are not alike. Non-like terms cannot, the emphasis is cannot. You cannot, trust me, you cannot be added. Okay, so we cannot add them. They are not alike, they are different. When we come to subtracting, same thing happens. Okay, so if I got 5a and I take away 2a, I'll get 3a. Okay, I can subtract like terms, but I cannot subtract non-like terms. Like this, my answer will be the same. I cannot subtract non-like terms. Non-like terms cannot be added and they cannot be subtracted. So non-like terms cannot be added. Let's add on to that, and cannot. Okay, the emphasis is cannot be subtracted. All right. Now SURDS work exactly the same way. So that what that means is, if I've got square root of 3 and I'm adding it to square root of 3, because they are both SURDS of roots of the same number, I've got two lots of them, I can add them. They are like terms. However, square root of 3 add square root of 5, this is what breaks my heart. Please don't break my heart. It is not square root of 8. We cannot add it. It is not. That is a very great crime against maths. Don't be a maths criminal. We cannot add non-like terms, and therefore SURDS that are not alike cannot be added. So if I want to add SURDS, I have to first of all check, can they be made alike or are they alike? Otherwise, I have to leave it like that. So I know square root of 2, add 3 square root of 2. There's 1 here and there's 3 here. Altogether, I've got 4 lows of my square root of 2. I can add them because they are the same. But if I have 5 square root of 2 and I add it to 2 square root of 5, hey, don't get fooled. Even though the numbers are different, they cannot be added. Why? Because the roots are different. This is root 2 and that is root 5. Again, they are non-like terms. Non-like terms cannot be added. Non-like terms cannot be subtracted. Therefore, when you are simplifying SURDS, you've got to check, are they alike? The same thing applies to when we are subtracting. We cannot subtract them when they are non-like terms, but we can if they are the same. So if I've got 10 root 2 and I subtract 7 root 2, I know I will have 3 loss of my root 2. Why? Because they are like terms. It is very important that we understand that like terms of surds can be added and non-like terms cannot be added. Like terms of surds can be subtracted, non-like terms cannot be subtracted. These are very important techniques and understanding to have. So how then was the secret? How then do I simplify square root of 18 and, for example, square root of 50? Now this is very different. It's difficult. Square root of 18 and square root of 50, they are not like. But is there any way at all that I could make them alike? Let's hang on. Have you watched the video on my second scale in simplifying sets? I know that if I were to break down square root of 18, I'm gonna get a number in the set that will have the same set as 50. What do I mean by that? Now, square root of 18 can be broken down into square root of 9 times by the square root of 2. I know the square root of 9 is 3, and then square root of 2 is just square root of 2. So my answer is 3 root 2. Now let's check square root of 50. Square root of 50 can be broken down into the square root of 25 times by the square root of 2. Again, I know square root of 25 is 5. And then the 2, I don't know it, I leave it. Okay, so now I have been able to simplify this question. This question is now very easy. It's basically saying I should work out the 3 root 2 add 5 root 2. Okay, so I'm working these two numbers out. They are now same roots. 3 root 2 add 5 root 2 will become 8 root 2. Now you can check this on your calculator and it will give you the same answer. So square root of 18, make sure to step and then add square root of 50. Remember to step your calculator for a space for your addition, so they are seen as two different things. When you add, the calculator says it's 8 root 2. Why have we been able to do that? We have to manipulate our numbers. We have to manipulate these sets so they have the same roots. Remember, they must be alike to be able to simplify. If they are not alike, we cannot add, we cannot subtract them. It is very important. Another example here. Now in algebra, we know if I have x times by y, I can just put them together. X times y is xy. And again, a times b is just ab. This is not any different from surds. If I have the square root of 2 and I times that by square root of 3, I can just multiply my numbers. 2 times by 3 is 6. So this will be the square root of 6. It is that simple. Multiplying sets is great. Now here's the beautiful thing. Secret. Watch this. If I have the square root of 5 and I times that by the square root of 5, because of this rule that says I can multiply them, I can therefore multiply 5 by 5, which is 25, and that gives me the square root of 25. But guess what? Square root of 25 is a rational number. It is not a surd. We can work that out, unlike the square root of 6 here. Okay, I know the square root of 25 is 5. So technically speaking, here's the secret. If I have the square root of 5 multiplied by the square root of 5, I can just say it's the same as 5. I don't need the square root anymore because it is a surd multiplying itself. So square root of 2 multiplied by the square root of 2 is just 2. Square root of 10 multiplied by the square root of 10 is just 10. This is fantastic, and this scale is a secret we will use to rationalize sets. Make sure you continue to watch my videos. One more thing on this is dividing. We can write division as fractions. All right, so x divided by y is the same as x over y. Okay, a divided by b is the same as a over b. What that means is if I have a squared b and I divide that by a b squared, I can write this as fractions as a squared b over a b squared, and therefore I can simplify. You can note that we've got the same b's there, and the a's are there. So these a's will become just 1a, and the b at the bottom will stay because the one at top will go away. We can simplify this fraction in the same way when we divide in SURDS. If I've got square root of 18 and I divide it by the square root of 2, I could tell that I could write this as a fraction, square root of 18 over the square root of 2, and I can divide 18 by 2. So 18 divided by 2 is 9. Now square root of 9, hey, there you go. It's a rational number. We can write that as 3. We cannot leave the square root of a square number inside without working out. That is a secret you need to know. If you can work it out with a calculator, you must, and you need, and you're expected to write the corrected answer down. Okay, so thank you for watching. Now be sure to watch the next video. It's about rationalizing SURDS.